He probably has to put videos up on YouTube.
All right, my name is Lyle with Safe Wire Energy, Chandler, Arizona. What we're going to demonstrate here is the power factor correction device. What we actually do is...
Could you speak up a little, sir, though?
What we actually do is we raise the efficiency of all the motors in your house. By doing that, we're going to do a power factor check on that motor just to show you how ineffective motors really are. All right?
Whoa.
Oops. Now, by doing the power factor on that motor, you can see by that gauge right there, that motor is only 30% efficient.
Okay, so a 1's perfect.
Right, 1 being perfect. By turning this on...
Now, we just went through a transformer there or something, correct, sir?
Right,
or a rectifier, or just a transformer?
We went through our power factor correction device. Now, because we're on 6 extension cords in the back, I cannot bring that up any higher than what it is. Normally, in your home, we can bring it up between 95 and 99%. So all your motors in your house will operate at that percentage. So by shutting those off and switching to amps, let me show you.
And this is the amp probe, the thing we just hook over our wires to measure the amp flow through the wires. And we want to get a look at this meter when it starts, sir.
All right.
Right now we're drawing 5.32 amps, it appears. And now you're going to flip the switch,
I'm going to flip the switch and turn our unit on.
We're going to turn our unit on. And now the same motor is drawing, it looks like a 1.64.
1.64.
So about half the amount of amps. And amps is what they charge you for.
Actually, that's 70%.
That's what your meter turns on. They're selling you amps. They're not selling you volts or watts. They're selling you amps.
Right.
And that's how electricity is measured. And I've been an electrician over 40 years, so I kind of know what's going on here.
Okay. What really happened here is the fact that this device really kind of acts like a monitor for your bus bar. This energizes the entire bus bar. And
so that ties in the bus bar, not the breaker then, correct?
We have our breaker right up on the top of the...
Oh, so you're back feeding through a breaker, basically.
We're feeding this bus bar through a breaker.
Yeah, well, to me, you're back feeding the other way. Instead of coming in from the meter, we're now coming from your device to the bus bar, correct?
Through the bus bar. Right.
That's what I'm saying. We're going the other way, just like a surge protection would almost be.
Not back through the meter.
No, but just from back through the circuit breaker back to the bus bar.
This actually is a device that will detect an inefficiency in a motor. Okay? So when this detects an inefficiency to a motor, whether it's your refrigerator or your air conditioning, it sends that inefficiency back to that unit, that air conditioner or that refrigerator or whatever motor it is. And say your refrigerator runs at 60% efficient. Well, what happens if you're paying 100% for your electricity? What happens to the other 40%? We store it in here in these capacitors. The capacitors store and release back to the same motor that it came from.
So you're actually storing energy in there through your capacitors.
I mean, we're talking nanoseconds. I mean,
and capacitors are what are used on fluorescent lighting to give you that kick charge to get your fluorescent gases going.
That's a different capacitor, but these
same idea,
here
right?
Are run capacitors that store and release energy. Okay, so we're releasing that stored energy back to the same motor that it came from, thereby raising the efficiency of that motor to where it should be. And the efficiency, you saw what it does for the amperage. Sure. So, yeah. That's it in a nutshell.
All right. That's pretty impressive. We're looking at doing a photovoltaic system, and I'm wondering if, we can actually downsize the PV system at all by installing this with the system.
Now, you're talking about residential?
Residential application, but it's got 2 tankless water heaters that are electric, so that's a pretty big draw when they kick on, plus an air conditioner, refrigerator, and a washer that only receives cold water and has an internal heater for heating hot water when it needs it, so that's probably got a pretty good draw as well. So,
okay, yeah, that's our main function is doing commercial work, but this is kind of a way for us to get our name out and run people that have commercial needs. Sure. So, other than that, I guess I've told you everything.
Sure. I mean, there's no difference. I mean, like if I want to put this on a residential unit, there's no different unit, right? I mean, this is still.
We have them for 100 amp panels.
Okay.
We have them for 200 amp panels. We have them for 400 amp panels.
All right.
All single phase, and then we have them also for 3-phase 400 amp.
Okay.
And then above that we go commercial.
Single phase is your household current. 3-phase is what we use in commercial current. That's why the gentleman is deciphering the two types here. And sir, about how much for a 100 amp panel would this little unit here cost? Now, it looks like that's what we're running on, is a little 100 amp panel here, aren't we?
This is a 200 amp.
It's a 200 amp panel?
This is a 200 amp unit right here.
And how much is it,
Okay.
sir?
Today for the show we're doing a $500 install price.
So $500 install and the unit?
Right, that takes install
everything.
means the unit, a 2-pole circuit breaker, 2-pole 30 amp circuit breaker, and then somebody to come and put it in within our 30-mile radius.
And you're in Chandler.
We're in Chandler.
And by the way, we're talking in Chandler, Arizona, of course, just to make sure everybody knows out there. So, thank you very much, sir.
You're welcome.